Very good afternoon, friend. We are here again with a wonderful master class today. Uh, on behalf of Vigyan Prasar, I welcome all of you here uh, in the fifth master class of 10th National Science Film Festival of India. Uh, we are going to have a very wonderful resource person today. Uh, we will we are having Mr. Nandan Kudhyadi with us, and very warm welcome, Mr. Kudhyadi. Uh,
Thank you.
but before handing it to you, with your permission, let me introduce you to our viewers. Uh, Friends, Mr. Kudhyadi has more than 65 documentaries to his credit on varied subjects. Several of them has won top national awards and have been screened at various international film
It's
festivals
great.
in Paris, Tokyo, Brussels, Vancouver, Busan, Hawaii, and others. His much talked about film Rasa Yatra has won the Golden Lotus National Award for the Best Non-Feature Film of the year 1995 for its sensitive and imaginative transposition of music into a dignified cinematic expression. It also won the Jury Special Mention in Brussels Festival. It was chosen for the NHK Asian Film Festival at Tokyo, as also for the festival at Paris. It has traveled all over the world as a part of NETPAC Asian Discovery Selection 1996. Mr. Nandan Kudhyadi graduated from Faculty of Fine Arts, MS University of Baroda, before specializing in film direction at the famous Film and Television Institute of India in Pune. He has worked with celebrated international filmmakers like uh, uh, Zanosi, apart from Mr. Manikal and Ketan Mehta. His cinemas has been excitement and energy of a new generation of filmmakers who are tackling contemporary issues with new perspectives and a keen insight into Indian science, culture, and society. Uh, thank you, Nandanji, for becoming part of this masterclass. And today we will be going to learn a lot from your cinematic experiments in making science films. So, the stage is all yours, sir. Sir,
Thank you
but
very
before we
much.
start, just want to elaborate how we will go. Like, we will have comments from all the different platforms where we are going live right now, and it will be visible there. And would you like to take question in between, or would you be taking questions at the end of the session, sir?
No, maybe after each film is shown, and something like that would be better than at the end.
Okay, sir. Okay, so
Yeah.
it's all yours, sir.
Okay. Good afternoon, everyone. I'm glad that we have so many people watching this program live. And like I was introduced, I actually graduated and did painting and artistry from Baroda before I joined the Film Institute. Now, just to make it clear that I'm not a science graduate, you know, and I want to put it across that you don't have to be a science graduate to make science films. That is something which is available to all of us. All that we need is passion and curiosity in science. Actually, the first question which came to me when I was doing my first film was, how do you make a documentary on Ramanujan with only three photographs available? And I was foolish enough to accept this challenge when NCSTC asked me to take on this project. rather than the CV Raman one, which they said you can do it after 2 years. So when I reached Bombay and I went to TIFR, I realized that Ramanujan's work is talked about only at postdoctoral level. And that is really impossible for us to understand. And to make a film for general public to be shown on television was an impossibility, you know. But I was taken to, I was suggested to kind of look at two volumes, two books which have been published by the Madras Mathematics Teachers Association, PK Srinivasan. And the two were Letters and Reminiscences, and the kind of mathematics, the kind of arithmetic which Ramanujan used to do as a child, you know, magic squares and different theories, and playing with numbers and so on. And it is reading these, especially the first volume of Letters and Reminiscences, really gave me a, a idea of his life, and really struck me as a tragic story, something which at the age of 32 he died coming back from England, and he had so much work, so much to give. Already he was uh, elected as FRS, and suddenly to know that he is going to die. Just imagine the kind of psychological trauma that he must have gone through. And that is when I felt that I need to dramatize this story with actors and enactments. And yet, it has to be a documentary. We are doing it for DST, so we can't take liberty with either facts or the kind of times there was and everything. The film has to be credible. It cannot be just my take on things. So we did a lot of research. We did a lot of study. We went read biographies, obituaries, all kinds of things to come up with a script which had which is recreating episodes from his life, and doing you know uh, recreating it with actors, period costumes, drama, even the way in which people used to live. What was the kind of social interaction? In what way was it done? And so on and so forth. So only after doing that research did we come with a script, and we went to Kumbakonam and different places and shot the film. Here I want to kind of emphasize that today the whole idea of this workshop is basically to kind of talk about out of box ideas, you know, experiments to visualize science narrative. And I can tell you that only with deep research can one really understand what would be the form of the script and the film. Because only when we do the research, then the research almost gives you an idea of what might be possible to do in this film. As you know, as we read books, a novel or whatever, we, in our mind's eye, we get images. you know if it is a story, we get visuals of that story in our mind, right? Similarly, when I write the script, I visualize. I kind of understand what could be the best way of shooting it. And it is there that I kind of realize that this is a story which needs to be told in form of interactions with actors playing different roles. And I got Raghubhi Yadav and Tom Alter. But before that, let me show you a clip of the earlier time. Ramanujan as a child and his passion and involvement with numbers. He used to say, "Numbers are like my friends." So let's see the first clip, right? Okay.
The place is Kumbakonam in South India, 100 years ago. Like every child, Ramanujan had a fantasy world. Only his were peopled with numbers. They became his friends. In their relationships, he saw an almost magical quality.
4 into 460 plus 420.
Huh?
No a big number. 325 into 325. Ah, so simple.
And so, each boy gets one banana. In the same way, if 1,000 bananas are divided among 1,000 boys, how many will each one get? Yes, yes, yes.
One.
You are good. And remember that whenever you divide a number by itself, the answer is always 1. Understood?
So if no fruit is divided among no one, still everybody gets one? What I'm saying is, if 0 is divided by 0, can the answer still be 1?
No, of course not. But there's nothing to laugh at. There are always exceptions to the rule. Bhaskaracharya. You all know who Bhaskaracharya was. He was India's last great mathematician. He said the answer was infinity. Today they say the answer is indeterminate. That was an intelligent question you asked. You like some, don't you?
Yes. You know, sir, I want to learn lots. I want to find out what the highest truth in mathematics is.
What? What did you say?
What the highest truth in mathematics is.
Ramanujan, people have tried, but no one has been able to find the answer to that question yet.
Not even Bhaskaracharya?
No one. Not yet.
The little boy realized that there were worlds of mathematics not open to him yet. His mind reached out to understand them, to discover those joys that lay beyond the scope of mundane school textbooks. In the beginning, senior students helped him in his aspirations. In due course, however, it was they who came to him for help. At night, college books would unlock their secrets to him. Loney's Trigonometry, a book that actually contains far more mathematics than its title suggests. Hyperbolic functions, infinite products, infinite series. Ramanujan was able to understand all these by himself. He started filling up notebooks with the work that he found so fascinating. The road to discovery culminated in finding a synopsis by G.S. Carr. Not only did it contain thousands of new theorems, but also a style of presentation without giving proofs, which Ramanujan adopted as his own.
it was a wonderful clip, sir, I must say. From which film is it, sir?
This is the Enigma of Srinivas Ramanujan.
And is it available somewhere to watch if someone want to watch the complete film?
Well, I think it is available on Vigyan Prasar channel.
Wow, wow. Okay, sir.
So with this, you would have seen the kind of detailing that I've done. You know, the the kurmi, that's the hairstyle of that time, the kind of munda that they were wearing, the kind of uh, 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 properties like that wooden cot, you know, that is there. And then this little boy spread himself underneath the wooden cot because he was told not to do so many sums and so on and so forth. You know? So he used to hide under the cot and do sums. It's very interesting. And you must have seen the the school that was there, you know, the the classroom and so on and so forth. So that is the kind of research that you need to do. You need to really know everything, almost everything that you can really think of. You know, we'll go to the next clip just so that we don't have much time, so we'll keep moving fast. And I'll come to the last sequence, the ending sequence with Raghubir Yadav and Tom Alter in Cambridge, and him reaching India and his death. Can I go? Next. Okay.
It was sometime during 1916 and 17 that Ramanujan came to realize the full magnitude of his wasted efforts, that almost three-quarters of his earlier work done in India had been mere rediscovery. A sense of dejection and worthlessness began to close in on him. It is
There
said,
is no visual,
in
it's
these
black,
moments
sir.
of deep personal
The
crisis,
screen is
Yeah.
black.
he even tried to commit suicide. The deepening sense of cultural deprivation on one hand, the cold, damp English climate, and his strict adherence to vegetarianism on the other, all conspired to make Ramanujan seriously ill. He was admitted to a sanatorium for tuberculosis.
Not again. Take it away. Take it away. Please. I hate your food.
There is no visual, the screen is coming black. So can we have this played
Yes.
again, sir?
Yeah. Okay.
It was sometime during 1916 and
Okay now?
17 that
Yes.
Ramanujan came to realize the full magnitude of his wasted efforts, that almost three-quarters of his earlier work done in India had been mere rediscovery. A sense of dejection and worthlessness began to close in on him. It is said that in these moments of deep personal crisis, he even tried to commit suicide. The deepening sense of cultural deprivation on one hand, the cold, damp English climate, and his strict adherence to vegetarianism on the other, all conspired to make Ramanujan seriously ill. He was admitted to a sanatorium for tuberculosis.
Not again. Take it away. Take it away. Please. I hate your food.
It's good for you, Mr. Ramanujan. Eat it all up.
Janaki. Oh, Janaki. No. Ramanujan, I just took a taxi cab, number 1729. Seems rather a dull number to me. What do you think? 1729. It is the smallest number expressible as a sum of two cubes in two different ways. Guess which? Who? I? 1 cube plus 12 cube, 9 cube plus 10 cube. Very simple. Is it indeed? Well, I suppose you wouldn't tell me the equivalent solutions to the fourth power? I see no obvious example. But I suppose the first such number must be a very large one. What's this? Something I wrote last night. You know, you drive yourself too hard. You know, Lord Narasimha comes to me, sometimes in my dreams. Through drops of blood, equations appear. What I write is only a fraction of what I see. From zero to infinity, from the beginning to the end. Circle. You know, on that ship to England, my fellow passenger was a doctor of tuberculosis, Dr. Muttu. Hush, Ramanujan, hush. I'm going back now. Home. With the same disease inside me. You've been elected an FRS. You are a success. They want you here. You must fight your TB. You must. Hardy, dear Hardy, you have been such a good friend to me.
Ramanujan returned to India and died a year later in 1920. He was only 32. It was only decades after his death that people began discovering the true depth and meaning of his work. Both in India and abroad, it is now being applied to various fields in science and technology, in computer programming, pyrometry, statistical mechanics, cosmology. The legacy of Srinivas Ramanujan is still very much alive.
Okay, so that was the Enigma of Srinivas Ramanujan, and that was the first film that National Council for Science and Technology, Department of Science and Technology, did way back in 1987. So you can imagine that was a time when documentaries were more or less like the film division documentaries. Put some photographs, put some interviews, and that's it. And show some live footage, whatever. But this enacting scenes with credibility, with authenticity, was something totally different, totally new. And that, I think, was my innovation. That was the first, this is the first docudrama film for at least science that I can think of in India. I can either take questions now, or I can, kind of talk a little more about the film. For example, when the film was made and shown, it was put for the national awards, and it didn't get any award because they could not pigeonhole it in, it was, for them it was neither a documentary because it's all enacted, nor a feature film because it's only 36 minutes long. And so they didn't, and there were no jury awards in those days, I suppose. So it didn't get any award. And I remember Dr. Segal, who was heading the NCSTC, told me, "Are Nandan, do something which will be acceptable to people. I don't want you, this idea of making innovative things in the field of documentaries, but do something for your CV Raman film, which is we need to give you. Do something which will be appreciated in the official circles with an award or something like that. So I came up with this idea of, again, enacting scenes from Raman's life, but with a presenter and voiceover and interviews. And then it got the best documentary, biographical documentary that year. But by then, that was 2 years later, 89, probably the jury had suggested to the ministry that it is no more good idea to have awards for feature films and documentaries. We should change the nomenclature. And they changed the nomenclature to non-fiction film category. No more documentaries. It allowed people to experiment, to do things differently, and that, I think, was a great thing at that point of time for us.
Nandanji, we do have few questions.
Yeah,
Uh,
great.
One question which is from Mr. Anupam Ghosh. He is saying the cast Raghubhi Yadav doesn't resemble Ramanujan. Does that matter? So, taking a question little further, like, is it always necessary to resemble exactly how your hero looks like if it's
Yeah,
a real life story, or can you take some cinematic liberty to express it in a different style, or what?
obviously. We recently saw a film on the great mathematician played by Vidya Balan. Does she look anywhere near Shakuntala Devi? No, we don't need to. What is required, because it is never going to be possible, right? So what is required is being true to the spirit of the person. Be able to kind of portray, to be able to kind of assimilate his qualities and portray. I remember Raghubhi Yadav telling me, we were friends, in those days. It was easy to kind of, and he said, Nandan, you are doing this film in English. मुझे तो English बिल्कुल आती नहीं है, तो मैं कैसे act करूँगा? So I said, don't worry. Ramanujan also failed in college because of English. So if you make mistakes, they will actually look very authentic. And let me tell you, every time I said cut, you should have seen the way his great relief. Of course, we had to cut that. So that's the way it is. You don't have to kind of does. If people have seen the film Man Who Knew Infinity, Ramanujan there is played by what's his name, that Indian actor,
Yeah,
Dev Patel.
Dev Patel.
He doesn't even look anywhere near Ramanujan, but that doesn't matter, right? Yeah. Can I have the next one?
Uh, Again, one question from me, because as we are talking about now, Mr. Anupam has asked about Raghubhi Yadav. So, when you were thinking of this film and of Ramanujan, like, was there any specific reason that you chose Raghubir Yadav? Why? How this thing came into your mind? Why you decided to cast Raghubir Yadav as Ramanujan? Like, and one more thing, like, uh, how uh, how much it's
अरे तू आता है
important
तो-
to have research, like what kind of research you had done before starting the film, or it was the process was going on while you were filming also, or you had completed the research work, and have you decided casting Raghveer Yadav after researching, and just wanted to understand the process.
Yeah. Not really. When I saw the three photographs that were available of Ramanujan, and when I decided that I want to do this film as dramatization with actors, then the first image that came to me is Raghubhi and Tom Holt, you know, because in a certain way, Raghubir Yadav actually epitomized that rural image that he kind of brings to his acting. He comes from a small rural background with the theater, folk theater, and so on. So, and I knew him because we were in Delhi, and he was in NSD, and we interacted, we stayed together, and so that was the obvious kind of, yeah, definitely. And yeah, when one is writing scripts, images, and we have to imagine with actors, some actors, finally, whether it works or not, but it's good to have a actor in mind so that it becomes easy for you to kind of think of him moving, the way he would dress up, and so on and so forth. So that I think is, yeah. Does it answer the question, or you have some other?
Yes, yes, yes. So, one more question. Uh, so, when we talk about science films, so it doesn't always means to have a very serious kind of monotonous kind of films, because the way you are, the science films can be very attractive and very beautifully made, rather than having it a very dry or something.
Yeah, that exactly is the challenge for us. After all, why are we doing science films? Most people think science is something which I don't understand. Mathematics, areba, not at all. So if we can make films in a way in which we get people involved into the narrative, into the story, with actors, with enactments, and so on and so forth, then people will find it easy to kind of get involved into the actual film itself, into the story, and then somewhere learn a lot of things. So my idea always has been to kind of take the fear out of science and celebrate science. Unless and until you celebrate science in your films, it will be impossible to. The So finally, what are we doing? We are basically not putting all the information, all the science into the film. That is wrong. That makes it information heavy. It becomes too difficult. The important thing is to make the film such that it excites people and make them curious about that subject. If you create that curiosity, then people will, now so it's even easier. People will go on the network and find out more about what aspect, whichever aspect that they want to kind of know more about, and so on. And once you have done that, I think your job as a filmmaker, as a science filmmaker, is perfect, is successful. Because if you if you make films which are boring, full of information, and not exciting, then why are you doing it? Let me tell you, it's like this. When I was in 8th standard, and that's when physics and chemistry gets uh, taught instead of just science, I had a fantastic teacher. He brought out the magic of chemistry, all the kind of reaction, this, that, and other. He could show us Newton's laws of physics. You know, it created so much interest in me that till end I took physics, chemistry, and higher maths. 9th, 10th, 11th. 11th was SSC in those days. But 9th, 10th, 11th, I didn't have that teacher again. And the whole joy of doing experiments, learning from experiential learning, all that got lost. It was all mugging. And by then I decided that I will take up painting and do artistry and become an artist, a painter. And then I joined the film institute. And when I came out of the institute, I had gone to Delhi. And there I met a scientist from DST. And as we were talking, I told him about this thing about my 8th standard teacher. And he said that you seem to be still excited about science. I said, yeah, there are reasons for it. And I went into it. This is not the place. But when I told him about it, he said, why don't you make science film? That is one way of going back to science. And there is this new council which has come up, the National Council for Science and Technology Communication. So why don't you work on something and give them a proposal? And so the first proposal that I gave was on C.V. Raman. Because Raman worked on acoustics and color. So for me, I thought that was fantastic. That as a filmmaker, that is what one would work on, audio visual. So I wrote a quick proposal, and the proposal was accepted and appreciated. And the committee there told me, oh, but Raman's centenary is 2 years hence. Why don't you make a film on, say, on Ramanujan, which is another 8 months uh, away in December? And I said yes. So this is how it happens.
Sir, more questions are pouring down. So, would we be answering right now, or can we keep it for later on?
Yeah, let's keep it for later on. Let's go to the next one.
Okay,
Uh,
sir.
C.V. Raman film. And
Okay, sir. So, friends, do not worry. We will try to answer most of your questions. Please send your questions and be with us. We had opportunity to talk to Nandan ji and ask all these queries which they in your brain. So, yeah, Nandan ji, we will ask question later on with next clip.
yeah,
life has been an utter failure. I was the first Asian to bring home the Nobel Prize in the scientific field. I thought I would build true science in our country. All we have now is a legion of camp followers of the West. There can be no salvation, no real advance at this rate.
He was one of India's greatest physicists, the acknowledged leader of the early scientific movement in this country. Nobel laureate, he is renowned for a discovery that bears his name, the Ramen Effect. Why then, in the twilight of his life, does he look back not with pride and satisfaction, but with pain? He was a man of strong convictions and innovative ideas, many of which are as relevant to Indian science today as they were at the turn of the century. This film is not just about the life of a famous man now no longer with us, but also a tribute to his genius. This is a film on the legacy of Sir C.V. Raman. The young Raman was curious by nature. He wanted to know more about everything that he saw and heard. For the rest of his life, this curiosity, combined with an inherent love for nature, drove him to study her many facets. Even at the age of 82, he was exploring new vistas as actively as he did as a child. For him, science had always been the key to understanding the workings of the world around him. Fascinated, he mastered such classics as Ganot's physics. There is a story that late one night, despite high fever, he refused to sleep till his father, a science lecturer, fetched a Leyden jar from his college and showed him how it worked.
See, a large amount of charge is accumulated at the bottom. You connect this to the electrode. It gets discharged.
Priya, there's a spark.
Raman was born near Tiruchirappalli in Tamil Nadu in 1888. From there, the family moved to the coastal town of Visakhapatnam when he was 4 years old. The sun, the sea, nature in all its primordial beauty here must have first stirred the young boy. He began to ask questions. His father encouraged his curiosity. As Raman's thirst for knowledge grew, he was spurred to take science up seriously in later years.
When light falls normally on a rectangular aperture, one gets a series of dark and bright bands symmetrically arranged around the slit's image. What if I hold the aperture inclined to the incident light? The diffraction bands are sensibly symmetrical when the incidence is moderate and asymmetrical when it approaches 90 degrees. The minima in this case are of course given by the usual equation. A cos theta minus cos phi is equal to plus minus n lambda.
What are you doing now, young man?
Sir, I'm trying to work out a new method of measuring the surface tension of liquids.
New method?
Why? Because by the usual method, either the drop is not steady or it falls down in the middle of the observation. So I thought if I could photograph the drop profile, it would be easier to calculate the surface tension.
Sounds ingenious. Carry on.
Oh, sir, Professor Jones, sir. One moment, please.
Yes?
Some time ago, I'd given you a paper of mine for comments.
A paper?
Yes, on unsymmetrical diffraction bands when the incident light is oblique.
Really? Ah, yes.
Perhaps you did. Well, it is nothing much to go by. Nothing at all. Carry on with your work.
Raman was not discouraged by Professor Jones's lack of interest. Instead, he took the initiative and sent his paper to one of the most respected scientific journals, the Philosophical Magazine in London. And it is to his credit that he had enough confidence in his first independent experiment to be able to send his findings to such a reputed magazine. For then, as now, education was a means towards a degree. Students were not encouraged to think independently or to use their initiative. Colleges in India did not have a tradition of research. Which, of course, brings us to a very fundamental question.
Okay, so here was a film which had its own questions, had its own problems in terms of understanding of how to put across. I should have spoken about this before because you have already seen. So here was somebody who had got the Nobel Prize for his Ramen Effect. So everyone knew about him. And yet, when he died, he was fairly disillusioned, fairly frustrated, you know. And when I got to know about it, my structure became clear. I said, let me start with this old man feeling disillusioned and saying, all my life has been utter failure. Now, once you have a man like him saying utter failure, naturally the audience is going to be curious. Why is he saying so? And the answer to it is revealed in the narration of the film. And that is how I structured the plot and the script. And other thing that and I bring it even before the main title, right? Another other thing that I want you to notice is that I have experimented in the language of cinema in a way. You remember the second shot, I mean the shot after the title, I use different times in one single continuous shot. The space is the same, but the times differ. Like you have the little boy, Raman playing violin, crossed by the old man. And then you come back and you see the presenter talking with the Raman Research Institute in the background. So that was again something which excited people to realize that here was something which is very cinematic, done very differently, and so on and so forth. So if we have any more questions,
We do have questions.
yeah, great.
Uh, uh, we had a question from Jesse Vikram. Uh, it is about how to make my film more cinematically appealing. Is my film is shot with labs where space is a problem? It's a very relevant question for the science filmmaker, sir.
Yeah, yeah. Actually, you will get your answer in my last film. The film which was shown yesterday, it's called Cellular Insights. And I will have a clipping of it in the end, if time permits, which is actually shot in the National Center for Cell Sciences. So you will get to know how to kind of work this out, the paucity of space, as you say. Yeah. So have patience. We'll reach there. Anything else?
Oh, yes. There is another question from Anupam Ghosh. What is your comment on background music score? A very good example is A Beautiful Mind. How do you go about this process? The
Okay,
process.
great. Yeah. Again, in the later film, okay. Now, for example, in Enigma, that you saw two clips, you didn't see the whole film. But when I was telling you that you have to do research, and you have to do research not just on mathematics but on very many different levels of reality of that time, in a sense, because after all, what is any medium of expression or communication is really a construct, right? We shoot bits and pieces of what is there around you, what we would like people to see, and we edit it, we put it together, and then we add music, we add sound, we add effects, and so on and so forth. So one thing that I would like my audience to know is that film is a construct, so is theater, so is dance, right? So we are constructing. It's the filmmaker who constructs, the dancer who kind of decides the choreography and so on, right? So when I was doing my research, I was wondering what kind of music. And I'd heard Mali's music. Mali is a flutist who is no more. But his life was very much like Ramanujan. You all know Ramanujan had a spiritual inclination, and he used to say that the goddess Namagiri would come in his dream, and all those things which he kind of ascribed to the goddess and Narsimha avatar and so on. Now, Mali also dedicated his art to the Lord. He would not play for an audience. He would say that I'm playing for, and imagine, once he came on the stage with full audience, and after a point he said, I don't want to play. I I don't think I'm in the right this thing to play for my God, and went away. And nobody stood up, and everyone appreciated. Everyone said, fine, that's him. You know, a American student one day came to him after 6 years of being a disciple, and said that I want to marry you. So he said, yes, marry me. To him, it didn't matter. His life was dedicated to his art and to his God. And so I used Mali's flute right in the beginning and again at the end. And you heard that Mali's piece when he's saying, my life is like a circle. On that ship to England was not Dr. Mutu, who was a TB specialist, and I'm going back to India with that same disease. And in the background, you have Mali's flute. Once you hear Mali's flute, you will remember the first time you heard it right in the beginning. So it helps you to recall. And so it becomes a circle really in its time. After all, cinema works in time. We have the added advantage of time, unlike a painting or a photograph, right? So
We had a very beautiful comment from Vikram, so I want to read it here. Vikram says that your film on Ramanujan is a book for science filmmakers.
well, Jesse, you have to wait. I have made 4 films on Ramanujan. and I'm going to show bits and pieces of it further. So the book is not complete. Picture abhi baki hai.
Sir, we are getting so many questions. Anupam Ghosh is again saying that I'm finding it difficult to choose a background music. His question was for music. He
Yeah.
says that a background music score for a video interviews for of researchers. Your suggestions, please.
Well, there is no formula. It depends upon what lab, what is your content, what is your subject, and the subject will dictate to you that this is the kind of music which will be suitable and which will not. Again, in the later Ramanujan film, you will find that I have used tanams, the South Indian uh, idiom of tanam,
Mhm.
using not more than two or three uh, 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 musical notes, and that was dictated by Ramanujan's fractions, his theory of fractions. You know, now when you do fractions, we in music, and music, as you know, is all mathematical, right? When you do
Yes.
fractions, you will reach Shruti, a concept which is only there in Indian music. You know, Western classical has very perfectly perfect notes, but we have a whole range of Shrutis in between the two notes, right? And that is how it is. I mean, you have to not use music as a background. The
Okay.
score has to have a certain significant uh, element to it. Like I
Mhm.
said about Mali's music, flute,
Mhm.
or the tanams, and so on. So when you hear more and more, you will find how I'm using music, and it will tell you how to do it or
Yeah.
how I do it.
Wow. One more question we will take, sir,
Yeah.
before going further. Like Khushi Acharya is, she wanted to know, I visualize ideas easily, but to bring the film to a beautiful conclusion becomes a difficult one. How to deal it?
Again, like I said, to me, research and deep research in the project that you're doing, in the subject that you're doing, will reveal itself. Let me tell you, have you heard of the story of the Zen master? Zen masters used to meditate, and then the disciples would meditate. And the master, when he felt that a particular disciple is ready, he would come and tap, and he would get up, and he had a realization. You know, so in a sense, we are like that. We have to meditate on a subject. We have to assimilate that subject, go deeper into it, and then that subject will reveal itself to you. Here is how I should be, because you will visualize that subject, and that is what is scripting, what is visualization, right? So you be like a medium. You just like a spawn, you should absorb everything about that subject. And once you have reached that saturation point, it will just ooze out. I'm not trying to be mystical. I'm just trying to be. It's like a Indian classical musician. He studies music for years and years together. Before, of course, nowadays they come on the concert much faster. But anyway, that doesn't matter. But only when you have reached that point that you don't have to think of what is today's raga, how many uh, what is the tal, what is the notes, 5 notes or 6 notes, and then, present it. No. Once you have absorbed that particular rag, it will come out of you spontaneously, you know. So, so you don't have to then think, is it a pancham, shadja, what? Nothing. It will just flow, right? You have to train yourself. You have to come to that point where films will come out of you. It should become so natural. In today's time, yes, we learn filmmaking with the mobile. In 2 weeks' time, you are ready to make films. Well, you can make films. Anyone can make films, right? But to make films which will have some value is something like. After all, we all write poetry. We all sing in the bathroom, but we don't become singers, right? We are not musicians. So that's it. Cinema is also a discipline, and you have to go through it.
Correct, so very rightly said. It's a discipline, and you cannot take it casually.
Yeah.
Anyone can make film, but it has to come from within, and there should be a thought process, and the mysticism what you were talking about. I think filmmaking itself is a mystic process. You are making you are creating a universe, so certainly mysticism is there. Even science is through science we are trying to understand the universe, the truth which is there. So yeah, mysticism, a
Yeah.
bit of mysticism is there.
Okay. Now I think we are going to get really crunched for time. I will go. I'll skip the fourth clip and go directly to Ramen Effect, because we all talk about Ramen Effect, Ramen Effect, but when it came to what is Ramen Effect, nobody can tell. Even school teachers can't. So what I did was recreated the Ramen Effect and delineated how, what was the thought process, what was the logic behind it, what were the practical difficulties, how did the students, his disciples, helped him realize it, and so on and so forth. Also, by then, what happens is you make the person human. you know we tend to kind of, once anyone reaches a certain stature, we put him on a pedestal and make him inaccessible. So my idea to make biographical films is to make that person accessible, to make his work accessible, to make it such that you can feel that he is somebody that you can approach. So let us go to the Ramen Effect one, which is the fifth one. So it will take me a little time to kind of skip that fourth one.
Okay, sir.
We'll have to skip now. Not this one. We go to the next. Not this one. Next one. Yeah. Right.
I'm beginning to wonder, is it fluorescence at all? Because if it's not fluorescence, then it should be scattering. Because Rayleigh scattering can be polarized, and it would be strong. Whereas the track that we have over here is so very feeble. Could it mean, is it not possible that it's not fluorescence at all, but altogether something new, something different? Not fluorescence, not Rayleigh scattering. You mean a new kind of radiation?
Sir, I've just studied the visible radiation excited by ultraviolet light in pure dry glycerin. It's strongly polarized.
What?
And the track is a brilliant green instead of the usual blue.
Green. A change in wavelength and polarized. This definitely cannot be fluorescence. This is something new. Boys, remember, I'd always said there must be an optical analog to the Compton effect. Is this it? You mean when X-rays are scattered by atoms, there's a change in frequency? Exactly. Just imagine, there's a change in wavelength with the scattering of X-rays. I think the same effect can take place with the scattering of visible light. But how do we prove it? The track that we have is too feeble. We should try and make it stronger. Probably we'll have to use a larger lens and complementary filters. Krishnan, I think you should follow it up.
Aye, sir?
Yes. I think I need somebody who can use the sunlight throughout the day. I've got my classes and Venkateshwaran's busy working, so he can only come in part-time. Besides, you've stayed away from experimental work for too long. Not at all healthy for a scientist, huh? This is marvelous news. Just wonderful. You understand what I mean? The first step taken in the research was to find whether the effect is shown by all liquids. The method of investigation was to use a powerful beam of sunlight from a heliostat concentrated by a 7-inch telescope objective combined with a short focus lens. This was passed through a blue-violet filter and then through the liquid under examination contained in an evacuated bulb and purified by repeated distillation in vacuum.
It's true of visible light, sir. It's true of visible light. There's still a track in spite of the complementary filter, sir. It's polarized. And there's a change in wavelength.
But links are still missing. How do I show that there is a change in energy or a change in frequency? Frequency, color. The spectrum, of course. The spectral lines will indicate any change in frequency. Ashu Babu, arrange for the spectroscope. Quickly, quickly! Where's Krishna?
Not come today, sir. Religious ceremony in his house. It's ready, Sahab, but the sun is setting. The light will not be strong enough.
Oh, dash it all. First thing tomorrow morning, huh? Next morning, I could see the spectral lines, but they were not clear. It occurred to me to change the light source, to use a monochromatic light. Ashu Babu, get me the mercury arc lamp. It's so clear, Krishnan, so very clear. In the blue-green region, there are 2 sharp lines instead of 1. What? Yes. Between the incident line and the new line, there's a distinct dark space. The new line must be of a different frequency. It shows a change of energy.
The new line that Raman discovered indicates the amount of energy lost or gained by a photon of light when it interacts with an atom of matter. This in turn tells us a great deal about the atomic and molecular structure of that substance. It was a momentous discovery that paved the way for new research in almost all branches of science. C.V. Raman was awarded the Nobel Prize for Physics in 1930. It was a moment of great significance, for not only was it a tribute to the man, it also officially put a country struggling for an identity on the scientific map of the world.
Okay, so here was Raman, and you saw how he struggled. This was during the British era, and to be able to achieve that was fantastic, isn't it? I think what we will do is we'll not really take too many questions now, because we are going to lose out on a number of clippings that I have. So let's go ahead to the next one. And here I want to bring in this, how important is research. You have to really get into that research. I was doing a 5-part series on Birbal Sahni, the paleontologist. You know, there is a famous institute in Lucknow, Birbal School, Birbal Institute of Paleontology. So I was working on trying to understand his life, his work, and I reached Punjab University, where his nephew was there. And he told me that, well, actually, uh, Babuji, that is Ruchiram Sani, Birbal's father, he had written some papers, and he had a notebook, and I think it's a bit of a autobiographical notes. I think, would you be interested? So I said, yeah, certainly. And when I read the first few chapters or whatever, you know, I saw that here was a man who could actually be claimed, who can claim to be the first nuclear scientist of this country. He had worked in Rutherford's lab in Cambridge when he had gone to visit Birbal and had written. But the thing was, it was all in different places. And finally, Dr. N.K. Sehgal brought it all together and published a book, Memoirs of Ruchiram Sani, published by Vigyan Prasad. So that is what it is. You know, it is not just film. It will lead on to many more things. Here in this case, a book. You know, first time people realized that Ruchiram Sani was so much ahead of his time. He used to conduct popularization of science in those days in Lahore, in mandis, in marketplaces. He would show experiments, he would create experiments and get people to learn. You know, that is fantastic. Nobody knew about it. Sehgal was so excited and he said, I never knew about him. You know, we talk about science popularization, and here is a guy who had done it all. You know, so let's quickly see a sequence of Ruchiram Sani, you know, working out an experiment in Cambridge with help of Birbal Sahni. Even when I'm talking, we can start. No?
And so it was. एटम का न्यूक्लियर मॉडल, जो कि सभी विज्ञान का आधार है, सिर्फ एक निरीक्षण, just a single observation, और उसकी सही समझ, करेक्ट इंटरप्रिटेशन ने विज्ञान के क्षेत्र में वो क्रांति लाई जिसकी कोई तुलना ही नहीं हो सकती।
तुम ज्ञान रूपी समुद्र की लहरों में खो जाते हैं और इस बार इस लहर को किनारा भी दिलाया है ना?
उत्तर, गैसेस द्वारा अल्फा पार्टिकल्स की स्कैटरिंग को मापने के लिए मैंने ये ढंग अपनाया है। ये गैस चेंबर है। इस गैस चेंबर में मैंने एक प्लैटिनम फॉइल रखा है और उस प्लैटिनम फॉइल में एक छोटा सा छेद किया है ताकि अल्फा पार्टिकल्स उसमें से जा सके और फोटोग्राफिक प्लेट पर पड़ सके। ये फोटोग्राफिक प्लेट इस अंधेरे चेंबर में रहेगी। बिरबल, तुम्हें मेरी सहायता करनी होगी। वो ये कि तुम्हें ये फोटोग्राफिक प्लेट डेवलप करनी होगी।
पर बाबूजी, इतने कठिन प्रयोग के उपकरण इतनी आसानी से बना लेना और फिर छोटी सी छोटी जानकारी ध्यान में रखते हुए।
अरे पुत्र, इतने दिनों से हम अपने घर के पिछवाड़े ये वैज्ञानिक उपकरण बनाते चले आ रहे हैं, तो हमारे इतने सालों का एक्सपीरियंस के जरिए क्या हम इतनी भी प्रगति नहीं कर सकते? I am entering into all these details because out of everybody else in the family, you were most interested in my work at Manchester. And indeed, I cannot forget the help that you gave me in my experiments during your holidays, which you and Bodhraj spent with me. Birbal Sahani inherited sterling qualities from his father and never accepted defeat either in his faith or his research. No matter how hard the task was, he was always willing to tackle it. It was an attitude of taking life as a challenge, almost the motto of the Sahani family.
Okay, we continue. So that was, somebody was asking about how the character should look like the person. You quickly maybe got a glimpse of that photograph of Birbal Sahni as a young man, and he looks so much like the actor whom we casted. But that's, sometimes it happens, and you have to look for it. That's it. Let me now jump to, because otherwise you'll think that I make only biographical documentaries. It was a time in globalization was the time, actually, in late 90s. And, under PV Narasimha Rao, everything got opened up, economy was in a different kind of a place. And science and technology had to kind of rethink as to how can we, till then it was a socialist kind of a program, right? We had national laboratories, and the laboratories did their research, and that's it. Now came the time when people were told, scientists were told, you have to generate funds for your laboratory. You can't just wait for government to fund your research. So we thought at that point of time, why not come up with the, and that was a time when only Doordarshan was available, right? There were no other channels. So I came up with this idea of a breakfast television show on science, the business of science, how business, science, economy works. And that's what I'll show you one small bit, and then we can go ahead and go to the next one. So business of science is what we are going to see.
Good morning and welcome to this, the very first episode of The Business of Science. This program is really intended to take a close look at the state of Indian science and technology establishments, and also how technology-based companies are positioning themselves in this age of liberalization, ongoing economic and political upheavals, and of course, the beckoning new millennium. So let's get on with our very first episode. And today, we take a look at whether the simple buffalo is going high-tech, and also if Antarctica is going to prove the next site for mass natural resource exploitation. But first, a quick report on the state of Indian science and technology. After 50 years of independence, in an era of global competition and cutting-edge technologies, where does India's large setup of science and technology establishments stand? Take a look.
Science, engineering, and economy constitute an interconnected web of network. So, how has globalization affected our science and technology institutes? Take, for example, the TIFR, totally dependent on government support to fund blue sky research at the cutting edge of scientific knowledge. An impressive example of this is the recent participation of a team of TIFR scientists in what is described as the most expensive project ever conducted in human history, the D0 experiment being carried out at the Fermi Lab in America. Globalization has affected the IITs in a different way. Today, 50% of its funds have to be generated in-house.
From a time, say 15 years ago, when the number of sponsored projects in the institute were 10 or 15, today in the institute we have 400 sponsored research projects ongoing.
The majority of sponsored projects come from national agencies like ISRO, HAL, etc. In areas like aerospace, with massive ongoing research programs, the Aeronautical Engineering Department can certainly continue to rely on a steady flow of projects to keep it afloat. But in the more competitive areas of research, where there is little or no government involvement, other R&D departments would have to look towards private sector support. One such department, which has been successful in managing to do this, is that of electronic engineering. Indeed, the industry linkage phenomena encompasses other central government research establishments too, like the National Chemical Laboratories at Pune.
Now, we have to distinguish research which are strategic in nature, like defense research, atomic energy, space research. These will continue to be funded by the government. What is in question is commercial research. I do not understand or agree why the government should fund research to make better ice cream or make better shoes. This the industry should.
Right now, what we're doing is basically applied research, which I think with the changing times, this kind of work will move to industry, and we will return to probably what we were doing maybe 40 years ago, which is going back to fundamental research. I hope that change will take place.
Seems to be a lot of cutting-edge technology happening out there. And now, how the Buffalo 2 is going high-tech.
Yeah, I'm cutting on time and going to next one and so on, because we just don't have enough time. We'll go to in 1995 there was going to be a total solar eclipse, and the government decided that this time, that is, see, in 87 there was a total solar eclipse where government actually encouraged superstitions, because what they did was they showed 3 feature films or 4 feature films back to back the whole time when the eclipse was to happen, because they wanted people to be indoors. They didn't want them to go and watch it, observe it. Now, after 7 years, they said that yes, we should get people to, so how do we motivate our audience, our people to watch the eclipse? When I did research, and I'm again underlining research, I found that we in India had a very ancient tradition of observing the eclipse, and not only that, it was described in Ramayana. And unless and until you experienced that phenomena, you couldn't have imagined something to write it, right? And then we also know about Mahabharata. Yeah. Yeah, just give me 2 seconds. Yeah. So we had Rama and Mahabharat also had the Jayadratha, who was killed by Arjun, but he had a boon. So so Sri Krishna worked out such that the battle would be held just in time for the eclipse to happen, and then used it strategically, and so on and so forth. So what I did was, like I said earlier, if you can take away the fear, then you have made it, right? So what I did was, I didn't want to tabulate so and so many times it has happened and we have always watched it and this, that, and that. No, people will not be interested. Somebody asked that question, all that information. So I used song and dance as a way of showing that is something which was so natural for us that we used to watch it, you know. And I've used this bar score as a way in which to do the presentation. So let's see.
देखो 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 किधर आके देखो 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 किधर आके देखो 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 आके आई देखो खाना भाई सपनों पे देखो चांद और सूरज का मेल देखो इंडिया से खबर से देखो टोटल सोलर एक्लिप्स देखो क्या संपूर्ण सूर्य ग्रहण देखो अरे सुनना सुनना सुनो 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 हमारी बात जरूर सुनो 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 हमारी बात जरूर सुनो जब भी तुम सूर्य ग्रहण देखो आंखों की रक्षा का ध्यान रखो सुरक्षित हेलमेट पहन के ये देखो नंगी आंखों से कभी न देखो मारा बाइस्कोप में वो डर नहीं बिना किसी खतरे का खेल देखो ओ पापा देखो आओ बेबी देखो पापा की मम्मी और पापा भी जरा देखो पापा की मम्मी और पापा भी जरा देखो बाबू मुशाय दीपे शो बाबू मुशाय दीपे शो ऐशो 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 मशीनों कमाल देख के जाओ ओ हमारा टाइम मशीनों कमाल देख के जाओ पास्ट देखो फ्यूचर देखो दिन में होने वाली देखो तारे सितारे और ग्रहों को देखो अरे तारे सितारे और ग्रहों को देखो पहले पुराने किस्से दिखाओ अच्छा बाद में कहानी आगे बढ़ाओ जो हुकुम लो वैदिक काल की बात है ये, अत्रि मुनि का आश्रम है ये, अत्रि मुनि का आश्रम है
साक्षात सूर्यदेव को निगल जाने वाला राक्षस स्वर भानु, अगर इसको पराजित करने वाली शक्ति कोई है तो एक ही अत्रि मुनि या उनके वंशज, सिवाय किसी में नहीं।
ग्रहण पर मंत्रों का असर ये कैसे हो सकता है?
सच बात तो यह है कि मंत्रों का ग्रहण पर कोई असर नहीं हो सकता। मतलब ये कि वैदिक काल में कुछ ज्ञानी लोग सूर्य ग्रहण कब होगा, उसका समय कितना होगा, इस बात का सही अनुमान निकाल सकते थे,
और शायद इसी का फायदा उठाकर वो एक महत्वपूर्ण व्यक्ति बन गए।
हाँ, अत्रि मुनि को जानकारी का पूरा लाभ मिला, ये तुमने देखा। जानकारी जिसको है ज्यादा, वो ही पाता बड़ा फायदा।
हाँ, बड़ा फायदा।
इसलिए हमारी बात मानो और तुम भी 24 अक्टूबर का ग्रहण देखो।
24 अक्टूबर का सूर्य ग्रहण देखो, 24 अक्टूबर का सूर्य ग्रहण देखो।
Yeah, we'll actually shift further into. I'll not show you another clip that I had. We'll go directly to jump in time to 2012. That was 25 years later than the first film on Ramanujan that you saw, Enigma. And here in 2012, government decided that 22nd of December would henceforth be celebrated as the National Mathematics Day. And then, well, they invited me, and I said that I'll make a film, sure, Now, how do I make a film which will not be a repeat, And what is it that we should be doing? That was the kind of question. So when I went to meet Raghuram, Professor Raghuram in ISER, Pune, he told me that one Professor Ken Ono in America had just 3-4 months back come up with the solution to mock theta function. And mock theta function is the last of the work that Ramanujan sent to Hardy. And so we contacted him whether he would be interested in coming to India. So he said, certainly, very much true. I'll be there. I'll give you 6 days. So we worked out, and how can you write a script and say to Ken Ono what he should say? How can I ask him, Raghuram, to say what, So all people are great mathematicians in their own way. And so, I came up with this idea of doing this film in cinema verite style. Cinema verite is, I can go into all that, is a way in which you make obvious that you are doing a film. You are actually recording with film or whatever, So there is no, so like I said right in the beginning, the construction. You show that you are constructing it, right? So because see, it works out best because we didn't have any script as such. We decided that we'll visit different places connected to Ramanujan and let people kind of talk about certain different aspects in that place. So we decided what aspect in what place, and we left it to visualize, to shoot as we went along. So one would quickly talk, okay, we'll do this, and we'll, and then we'll move from here to here. And that was all that we really actually planned during the shoots. So let's see the genius of Srinivas Ramanujan. And it's like a pilgrimage of 4 or 5 people, all of us traveling from one place to another, in search of Ramanujan, in that sense.
I was a teenager living in Baltimore, Maryland in the 80s. A letter came from India addressed to my father. It was a letter from Janaki Amal, Ramanujan's widow. And she was thanking my father a gift he'd made. It was a contribution to the making of a bust of Ramanujan. I didn't know who Ramanujan was, so I'd ask, who was Ramanujan? Ken, we are way to Kumbakonam. It's a journey of discovery.
In the spirit of pilgrimage, visiting places associated with Ramanujan.
Ken, Ramanujan had a good sense of humor. When Tanjavur was suggested to him, he was sick. He said, Tanjavur? I don't want to go there. It reminds me of Tanjavur. He was punning on the word Tanjavur. The place where I died is what it means. I don't want to go there.
And he can say that, the last letter that he wrote to and get on. What you are saying?
This documentary is an attempt to imagine the cultural and mental landscape of Ramanujan, to bring to light his intangible presence. The depth of his creativity can only be allured to make evident his place in the history of mathematical thought.
This is the Krinan bungalow where Ramanujan stayed for a couple of months before he shifted to Gometra, where he unfortunately died. Illness.
Gometra is where he studied the Mach theta functions, right?
Yeah. Why Mach?
Why Mach? Yeah, that's the question.
Well, Mach theta functions, I've spent years thinking about these functions, and what you just asked is the main question. So for many of us working in number theory, the mathematics in Ramanujan's last letter, the very last letter he wrote to Hardy, has been a mystery to us. This letter was written in 1920, and until very recently, the question you just asked, why Mach, is exactly the question we would ask, except we didn't know what the Mach theta functions were. And it turns out a few years ago, there was a great thesis by a Dutch mathematician named by the name of Saunders Wegers, who finally figured out what these Mach theta functions are. Very technical object, but it turns out that with this understanding, we've been able to prove lots of wonderful things in math physics, and probability theory. It's been incredible.
Is this is a Mach theta function and the rest of it useful today in current day mathematics?
Oh, absolutely. I'd like to think of Ramanujan's last prophecy as a treasure trove of math. People are even using them to study black holes.
Black holes?
Black holes.
Oh.
And you see, this discovery of the Mach theta functions, the discovery that Wegers made, is quite a historic event for mathematics. There have now been many applications in mathematical physics, combinatorics, and number theory. It's really an incredible sequence of events. I'd like to think of it as this. Our understanding, which is only the result of the last 10 years of work, is the realization of perhaps Ramanujan's last prophecy.
Yeah, so this is the way we make it evident that we are shooting this, right? It's like what you saw till now was recreations that I did. And now I'm deconstructing the recreation. We are almost showing you how the film got made, how it evolved, the way we planned out, and we are showing the plan, right? So that, in a way, is a very Brechtian device, you know. Anyway, so when I have a 4 hour workshop with you guys, I'll go into all details. So let's quickly go to the next one, and maybe go into, maybe miss out on the next one and go directly to the next. So I would rather that we skip one more and go to the legacy film, which is my fourth film, and then we will go to my third film.
One particular year is as good as any to celebrate the memory of a great mind, and the government declared the birthday of Ramanujan as National Mathematics Day.
Mathematicians are remembered not only for their theorems, but also for their insightful conjectures or intelligent guesses they believe to be true. One example is Bertrand's postulate. The French mathematician Joseph Bertrand will forever be remembered for the conjecture he made in 1845 when he was just 23. Bertrand observed that between the number 3 and 6, there is a prime number, 5. Similarly, between the number 10 and its double 20, there are 4 primes, 11, 13, 17, and 19. Generalizing this observation, Bertrand postulated that between every number n and its double 2n, there is at least one prime number. And Bertrand checked that his postulate was true for all numbers less than 3 million. However, this still does not constitute a proof. For example, it does not show that there is a prime between 5 trillion and 10 trillion. It was the Russian mathematician Pafnuty Chebyshev who 5 years later gained immortality by proving this result, and the postulate was promoted to the status of a theorem. However, Chebyshev's proof of the result was long and complicated. In 1919, Ramanujan provided an elegant 2-page proof of this theorem in an article that appeared in the Journal of the Indian Mathematical Society. His proof gave rise to the notion of what are now called Ramanujan primes. Interestingly, 13 years later, unaware of Ramanujan's proof, the Hungarian mathematician Paul Erdős, then just 18, gave another proof. This proof, although similar to Ramanujan's, contained a new idea that allowed Erdős to generalize Bertrand's postulate in an entirely new way. Just as Bertrand's postulate inspired many mathematicians, including Ramanujan, Ramanujan's conjectures have in turn inspired other mathematicians to enlarge the edifice of mathematics, brick by brick.
Quickly. So, this particular film, we go into what is the relevance of Ramanujan today. First we build this up, the story, and then in the end we kind of talk about his relevance. And actually, you would be surprised. I don't want to give it away. In way in which it is Ramanujan alive for us today. Yeah, let's see that. Next one. Now, in this particular,
Ramanujan was a pure mathematician who was interested in numbers for their own intrinsic beauty. But, surprising as it may be, his work still has an impact on our daily lives. For example, Ramanujan's work tells us something about how to build transportation networks. Consider a road network between different cities or between different centers within a city. Google uses these networks to recommend alternate routes. As I'm sure you've experienced, these road networks are very prone to failures. Sometimes intersections become overly congested or they're simply blocked off. So one wants a network with many alternate routes. Specifically, even when several nodes are congested, one would like to be able to have high connectivity between different locations in the city. Building a robust network then corresponds to constructing a graph with a large spectral gap. In 1988, three mathematicians, Lubotsky, Phillips, and Sarnak, constructed a class of graphs that achieved the maximum possible spectral gap for a given sparsity. These graphs came to be known as Ramanujan graphs because their construction used a 1916 conjecture of the Indian mathematician. This conjecture was later proved by the Belgian mathematician Pierre Deligne, who was awarded the Fields Medal, the most prestigious prize in mathematics. A second application of Ramanujan's work is important for modern web applications such as Facebook. In particular, Ramanujan-type graphs arise in the design of algorithms for detecting communities or groups of people with shared interests in such social networks. The study of such randomized algorithms is a part of the field of probability theory, which is my own domain of research. Thus, we see that Ramanujan's work from the early 1900s continues to have a profound impact on both fundamental and applied mathematical research to this day.
Ramanujan's discovery are not like discovery with proofs. It's discovery through intuition. Okay? So he conjectured, the existence of this mock modular forms. These are some very, very special modular forms which are being, whose properties are being unearthed even in mathematics only now. There's a work by string theorists and mathematicians together, okay, in trying to understand some new properties of some, black holes, tiny black holes, and in which this is all married together, and it's a wonderful unification.
Okay. Now, here is a film which we just saw, which at the earlier 2017 Vigyan Prasad Festival got three top prizes. The one which really made me feel good was the first one on research, best research and best direction, and then the other one. And more importantly, the chairman of the jury was Professor Partho Ghosh, the very, very well-known, celebrated science week. So, I was really happy. I'm going to miss out on my film on conjecture, which you can actually see on Rajya Sabha television. If you go on that, you'll be able to see the whole film. And I think you should do that because there is really not much time. And I promise you that I'll show you Cellular Insights. Yeah. So let's go directly to Cellular Insight. He will try to fit that when I'm talking about it. Cellular Insights is a film on the 30 years of work of National Center for Cell Sciences, and again, generally our clients just tell you, okay, we have this. Go for it. So, our clients generally say, okay, we are celebrating 30 years, so why don't we do a film? But here what I did was, like I said, when one does research, so now molecular biology is something obviously I was aware of, and I also was aware of the fact that Robert Hooke was the first one to peer into a lens and see the cell for the first time. And he described it and drew it, and it was a cork cell. He had put a piece of cork, and he had seen these cells. So I wanted to make use of the fact of the cord cell, you know, and why not use it as a kind of a sutradhar, you know, who pulls everything together. And this cord cell, after 200 years, visits the National Center and is astounded by the kind of developments. He can't even imagine what's happening here, you know, and that excitement is kind of rubs off into the audience. And then we thought of using this film to attract students. They wanted more and more students for their PhD, you know. So I came up with this idea of doing a kind of a story, reading a story of a young PhD student wanting to kind of decide which niche area she wants to join in. And so she goes through the entire center, visiting different labs. And let's get going on this.
It was around 1990s that biotechnology was ushered in India and stimulated a renewed interest in the mysteries of cellular life, with far-reaching progress that you witness today. We cells are the basic units of life in the plant and animal world, including you humans too. Each cell in the body has a specific characteristic, dictating its interactions with other cells, molecules, microorganisms, and the surrounding tissues. Plants and animals are composed of trillions of microscopic cells of different types. And I have the honor of having been the first to be observed as a cell by Robert Hooke in 1665, which I should say made visible for the first time our hitherto unexplored microscopic world.
Ever since I first peered through a microscope, I wondered, how do these tiny little cells organize themselves into a walking, talking, thinking human being? This question led me to pursue a career in this exciting field of biology.
20th century witnessed a remarkable growth in almost all the branches of science, and molecular biology was no exception. In the 1950s, Sir Francis Crick postulated the central dogma of molecular biology. This stated that DNA was an information storage molecule capable of replicating itself and transmitting information. This information has to be read in order to put together the amino acids in a specific sequence to ultimately synthesize every distinct protein through an intermediate step of another molecule called RNA.
This flow of information is regulated at multiple stages to control the production of certain specific proteins at any given time in response to different stimuli, such as a cell being attacked by a pathogen, a stem cell differentiating into a particular cell type, or a cell simply undergoing division. Any deviation from this precisely controlled system causes serious molecular upheaval, resulting in major diseases such as diabetes, autoimmune diseases, and even cancer.
Cancer claims among the largest number of victims every year worldwide. And NCCS researchers have put in considerable efforts into tackling this menace since the early days.
Okay. So this was a small bit that I thought would kind of give you an idea of how this would the film would develop. And those who have seen it yesterday would find, it's a recount for them. Yeah. So I think
Sir,
we should get some
yeah,
questions.
Nandanji, as we had only 5 minutes left, so we will take one or two question.
Okay.
Yes. So again, this question is from Jesse, and the question is: how will you differentiate traditional forms of filmmaking with current filmmaking scene, a sense and aesthetically, especially in context to ideas of innovation?
Okay. One thing that you should realize is that cinema has only a history of 100 years. It's not been a long tradition at all, and we have innovated all the time. Innovations happen just like it happened with the Robert Hooke, with that little tiny glass piece. It changed the entire development of, the new development was biotechnology, biology. Before that, nobody had seen that microscopic world at all. Similarly, with cinema, it has always been the technological innovations which allowed us to create new ways of doing things. You know, that the first cinema was because of a certain way in which people could, the guy could record movement at 24 frames per second. And when it was shown again at 24 frames per second, because in those days for 19 frames, but whatever. And that's why you had this kind of a slow motion kind of a thing, of a sort. But what I mean is that look at today. Today it's digital, not even video, it's digital in that sense, But right in the beginning, my India Se Khabras Dekho was probably shot in low band video, pneumatic, right? And you can see the kind of quality. It's like flaky, right? So, but that allowed us to do certain kind of things which my films didn't. My earlier two films, the Enigma and CV Raman, were shot in 16 mm, right? It's a totally different technology altogether. And look at today, you have small little cameras which can go anywhere. It can sit on my shoulder and see what is happening there, right? So that's a kind of thing, and that allows you to visualize differently. It allows you to think of doing films which you had never thought of, because you are able to kind of use that new technology. And that is important. We always ought to be open to technology, open to new ideas, new possibilities. So whenever my students used to ask me, and I would tell them, I cannot teach you for this technology which you are using, but I want you to learn. If I have to tell you something, I will teach you to be able to face new technologies. I studied in FTI, and that time there was no video at all. There was only films, 35, 16 watt. That was the gauge. But with video, things changed. And I learned outside by doing mistakes, right? So you ought to be able to see changes and be able to kind of assimilate and let it be positive. See what are the possibilities and think in those terms.
Okay, very nicely said, sir. But before we conclude the session, do you have any message for the upcoming or advice for the upcoming filmmaker or upcoming science filmmaker, sir?
I think I just gave you that advice. Be open, be welcoming to new technologies, new possibilities of science, and put that possibility in front of audience in a way that they will be able to understand. To be, for them to understand, you have to understand first. Like all the time that I've been saying, research, understand, assimilate, think of ways in which that what you have learned can be projected in simple way to be able to tell the audience, right? When we use the big word biotechnology, people, Are, what is this? But when I tell them it's something that we have been practicing every day in every house since the millennium. Don't we make dahi from milk? What is that? That is using biotechnological concept, right? So that is what I would say, that you ought to be able to kind of do all the research, put it in a way which will be understandable for people, which will be entertaining in a certain way. Yeah. And so once that fear goes, and how does the fear go? Not by saying don't fear, but by letting them imbibe, enjoy what is being said, shown, right? And once they do that, they will actually understand and get excited. And if we can create that curiosity amongst our audience, that's it. That is what my my understanding of science film should be. Not giving them the entire history, telling them in detail what are the different aspects of it, this, that, yeah, no. No textbook. We don't want to create textbook. We don't want to kind of be a thing for a teacher. No.
Thank you very much, Nandan sir. I wish that we could continue this session for one more hour, but the time is we have the restriction of time. Friends, it was Nandan sir, one of the finest science filmmakers of our time. And sir, we are getting so many responses from our viewers, like beautiful session, learned a lot, and thanks. You had explained the complexity of science film in such a simple and an artistic way that that the message has been received, like they got what you want to say. We hope to have many more sessions with you in near future, and thank you very much for taking your precious time and coming for the master class. Thank you once again, and thank you very much, sir.
Thanks a lot. Thanks a lot to kind of find such receptive audience that they came up with all these questions, and you know,
yeah,
it's great. It's fantastic to kind of be appreciated. Who doesn't want to be appreciated? Yeah.
yes. So friend, this was Nandan's sir, and as you know that we are a film festival, online film festival for 10th National Science Film Festival of India is going on. You can see so many nominated, 116 nominated films till 12 midnight today, because it's online, so it won't be available from you cannot see it apart if you cross the deadline. And Nandan sir was kind enough to explain so many things, and we hope to have him for for the future workshops with us. And please do participate in the upcoming uh, panel discussion, which is from 4 o'clock. And do not forget to watch the very awaited event of the festival, that is award ceremony, here live on the Facebook and YouTube channel today evening from 5:30, where you could see the films. You will know the films which is going to win the award. So thank you very much. See you soon. Have a great day. Thank you, sir.